Point 3 covers piecewise functions. Starts out telling you some graphs are defined by different equations over different sections of the graph. These graphs may be continuous, or they may contain breaks. Continuous means that you can draw a picture of it without ever having to lift your pencil up from the paper. A break means that you have to lift your pencil up before you can draw the next part. As these graphs tend to look like pieces glued together to form a graph, they are referred to as a piecewise function. Piecewise functions are functions that have different rules for different parts of its domain. Their pieces may all be linear or a combination of functional forms, such as a constant, a linear, quadratic, cubic, square root, cube root, exponential, etc. Due to this diversity, there is no parent function for piecewise defined functions. The example below contains linear, quadratic, and constant. So this is an example of a piecewise function. It has three different pieces. This first one, x plus 2, is linear, but we're only interested in the part of that line where x is less than or equal to negative 1. The next one, 1, that is the horizontal line at y equals 1, but we only want a segment of that where x is between negative 1 and 1. And then the last one, x squared, that's your parabola, but we're only looking at the x values that are greater than or equal to 1. So remember that domain is the value of your x's that you put in, range is all your y's that you get out. So first we're going to look at how to model with a piecewise function, which is just a word problem. So the problem says, Alani has a summer job as a lifeguard. She makes $8 an hour for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times her hourly pay, or $12 an hour, for each hour over 40 hours. First, how could you make a graph and write a function that shows Alani's weekly earnings based on the number of hours she worked? So if I want to make a graph, I need an XY table. So my XY table, right? So remember X and Y. X is what I put in, so X is how many hours she works, and Y is what we get out. That's the pay that she gets. Okay? I know that if she doesn't work at all, she makes $8 an hour. Okay? I don't want to start my graph all the way down at x equals 0, okay, because I know that we're getting up to at least 40 hours and beyond. So I'm going to start my XY table at 20 hours. And then I'm just going to go in increments of 5. So I'll do 25, 30, 35, 40, 45, 50, and 55 should give us a nice graph. So for these first 40 hours, we make $8 an hour. So if she works 20 hours, 8 times 20, 160. 8 times 25, 200. 8 times 30, 240. 8 times 35, 280. 8 times 40, $320. Now, for any hours that she works over 45, she makes an additional $1.5 times for her hourly pay, or $12 an hour. So for the first 40 hours, she still gets the $8 an hour. So if she works 45 hours, she got the $320 for 40 hours, plus 5 hours at $12 an hour. So that's $320 plus $60, $380. And then I would just, if I'm incrementing it by 5s, I would just add 60 to this. So 380 plus 60 puts us at 440. 440 plus 60 puts us at 500. So now that I have that, I can go ahead and draw my graph. Down here, these are the hours that we work. We have from 20 to 55, so I'm just going to go in increments of 10. So I'll do 10, 20, 30, 40, 50, and 60. Then our pay, 160, so I'm going to start at 100. I need to go all the way up to 500, so we can just go by hundreds. 200, 300, 400, and 500 at the top. And I'm just going to plot these points. So at 20, we're at 160. So this is my halfway point. a little bit past that. 25, we're at 200. 30, we're at 240. 35, 280. 40, we're at 320. Notice that that part, I can draw a nice straight line. Now, my next part at 45, I'm up to 380. 50, we're at 440. And 60, we're all the way up at 500. So notice that my graph then kind of veers off this way. So there's our graph. Now we want to write an equation. This first line here is going to be easy, right? Because it is a constant rate of 8. So this is just f of x equals 8x. For every hour she works, she gets $8. This next graph is the 8x plus what we did over here, the 12x. So I can start out and say, okay, we are looking at $320 for the first 40 hours. Then we have to add to that $12 for every hour she works past 40. So I could say x minus 40. So then I'm going to work that out. 320 plus 12x minus 480. So when I combine like terms, I end up with 12x minus 160. So the different pieces, my different pieces, f of x is equal to, I'm going to write it like this. The first one was 8x. I'm only looking at 8x when my domain or my x values were between 0 and 40. So 0 less than or equal to x, the hours she worked, less than or equal to 40. My next piece, 12x minus 160, and that is only when x is greater than 40. Okay. So now we're going to look at the next page where we're going to learn how to graph these. So this is what our piecewise functions are going to look like. It tells us that if the domain contains a greater than or a less than, no equals to sign underneath it, there's a hole in the graph, which we represent with an open dot when we graph, because that point is not included in our domain. If the domain contains less than or equal to or greater than or equal to, we will have a closed circle. That is in our graph. So the first one, we have f of x equals x minus 1 quantity squared when x is greater than or equal to 1. X plus 3 when x is less than 1. So I want to make an xy table. So for the first one, I'm looking at x minus 1 quantity squared, but I only want when x is greater than or equal to 1. So I'm going to make an xy table. The very first x that I'm going to put in is 1 because that's where they're telling me my domain starts. Then I want all numbers bigger than 1, so I can go 2, 3, 4, 5. Get my y's, I plug this in. So 1 minus 1 is 0, 0 squared, 0. Plug in 2, 2 minus 1 is 1, 1 squared, 1. When I plug in 3, I get 4. Plug in 4, I get 9. 5, I get 16. Now I'm going to make an xy table for the other one, x plus 3, but I'm looking where x is less than 1. So this xy table, again, I'm starting at 1 because that's what's in my domain. Now I want x is less than, so my next number, whole number smaller than 1 is 0, -1, -2, and I can go up to -3. Plug these into this equation. 1 plus 3 gets me 4, 3, 2, 1, and 0. So now I want to plot these points. So if I plot the x minus 1 quantity squared, notice it has the equals to sign, so it's all closed dots. So the first point, 1, 0. So over 1, 0, closed dot. 2, 1, 3, 4, 4, 9, up here. I know that this is a part of a parabola, so it's going to be U-shaped. So I have this U with my arrow. Now I want to graph the line, the linear part. My very first point was at 1, 4. The 1 is not included, so here I'm going to have an open dot. So over 1, up 4, I'm going to do an open dot. 0, 3, negative 1, 2, negative 2, 1, and negative 3, 0. I want the rest of all of this keeps going, so that's my graph. Again, this is that U shape. So now we want to identify the domain of the entire function, everything that's shown. So I notice with the line, I start way out here at negative infinity because these are my x's, everything is included. I go up here to 1, 1 has an open dot, but when I jump to my other graph, it was a closed dot, so 1's going to be included in the entire function. And then this graph, my parabola, all the x values are included in the positive direction, so my domain, negative infinity to infinity. Range are my y values. So again, I look at what's the smallest y value. I have every negative number, every positive number, so my range, negative infinity to infinity. Now we want to talk about the intervals that are increasing, decreasing, and constant. And remember, these are my x values only. We always read our graph from left to right. So if I start here from the left, this line from left to right is increasing. Then I jump to the parabola from left to right. I'm also only looking at the part that's increasing. So my entire graph is increasing, negative infinity to infinity. It is never decreasing, it is never constant. So that was graph number 1. So now I'll switch colors so that we don't get confused on graph number 2. So now if we look at graph number 2, I have 3 pieces. I'm going to graph those 3 pieces. The first one is just 0. Right? So it's telling me that all of my y values are 0 for these x values between negative 5 and negative 2. So negative 5, negative 4, negative 3, negative 2. That's all that I need there. So if I graph that part and notice that the 2 doesn't have an equals to sign underneath here, so this is open at 2. So if I plot those points, negative 5, 0, closed. Negative 2, 0 is open, and then I'm just connecting those two. So that's the first part of my graph. So now I want the negative x squared plus 4. So negative x squared plus 4. I'm going to make an xy table. Here I'm only looking at x's between negative 2 and 1. So negative 2, negative 1, 0, and 1. Everything is closed, so these are all closed. Plug those in. Negative 2 squared is 4, but then this negative out front makes it negative again, so I end up with 0. This gets me 3, this gets me 4, this gets me 3. I'm going to plot this point, so negative 2, 0. Here, inside my open dot, I put a closed dot. Negative 1, 3, 0, 4, and 1, 3. And again, this is a parabola, but it doesn't continue because the domain is restricted. So I do the U and I stop. So I do negative x plus 3. But again, the domain, they are restricting me. They only want between 2 and 5. So 2, 3, 4, and 5. I see it at the 2, I'm going to be open. So plug these in, negative 2 plus 3 gets me 1, 0, negative 1, negative 2. Plot these points. Over 2, up 1 is open. 5, negative 2, closed, connect. So those are the pieces of my graph. I want the domain of the entire graph. So I start here at negative 5. It was closed, so negative 5 in brackets. Up 2. It stopped at negative 2 open, but the next graph had negative 2 closed, so it's included. I go over here to 1. 1 is open, closed, so included. Then I jump over to this, so I don't have any numbers, x values between 1 and 2. So we put a little U, which means the union, or just a fancy way of saying and. I pick up at 2, but it was open, so parentheses, 2, it stops at 5, which is included, brackets. So there's our domain. Our range are the y values. So the smallest y value I have on my graph is -2. It's included, so bracket -2. The highest y value I have is 4. It's included, so also brackets. So now I'm looking at my intervals for increasing, decreasing, and constant. So increasing from left to right. This part of my parabola is increasing from -2 to 0. So -2 to 0 is increasing. Decreasing, this part of my parabola from 0 to 1 is decreasing. Then also this line is decreasing from 2 to 5. So union or and 2 to 5. Then constant. So this horizontal line stays constant. It stays constant from -5 to -2. So -5 to -2. That was as far as we got day 1 in class today. We will pick up with example 3 and 4, and then the rest of it tomorrow in class.